Hi, welcome everyone to this webinar on Automation Studio E7 Educational Edition. Today is the part 4 of our multi-technology project. So we will review today how to apply faults to the schematic and also how to apply permissions on that same project so students may not have access to see the properties of the components and maybe also not able to modify the schematic. Okay, so if we review a bit what we've done over the last 3 weeks, so the first part was actually when we designed this illustrated pneumatic portion. The second part, we did the electrical part. We try to focus this webinar on using the illustrated components of Automation Studio. We've been doing symbol schematic for the last 30 years, so people know about that. But this new illustrated view is something that we implemented since COVID. A lot of our customers actually said that they've lost access to their trainers. So for them, being able to do more like a wiring diagram really help students transition from theory to practice and also help them while they did not have access to their trainer. Okay, so we've done the motor control part. Then we also inserted a illustrated view of a compact logic PLC. The third part, we actually wrote the program with the AB5000 to control the different systems. So basically when I push start, I extend the cylinder. After a certain time it retracts and so on. Okay, so now the part for today will be on applying faults to this project and the permission like we talked about it before. So thank you again for joining us this morning, and let's start the presentation. Since we are too many people connected to the presentation today, we will not be able to answer your question as we go during the presentation. So if you can write your question in the interface of the GoToMeeting, we will answer them at the end. As well, at the end, we'll have more time to give you the mic if you want to actually formulate your question yourself. Thank you. Okay, before we start on the actual multi-technology project, I want to just talk to you about globally about the troubleshootings in Automation Studio. Okay, so every technology basically that we have besides the ladder diagram here, you can actually apply faults on components. For example, if we go on hydraulic, I can take a pressure relief valve like this, for example. Okay, let's do a very quick circuit, okay, just so I can show you a bit what these faults can be triggered like. Okay, so I'm going to do this very quickly here. We've done it very more detailed in the past webinars. So let's just connect this here like this, and I can return this to the tank. Hit the control key, copy this here. Let's zoom all. Okay, let's say this is our hydraulic circuit. Okay, it's very simple. If I simulate, everything works well. I can trigger the valve back and forth, so everything is okay. Now, if I want to apply a fault on a component, if I click twice on this pressure relief, for example, we have here in the data all the properties of this pressure relief. Okay, we also have like operating conditions, maximum flow, maximum pressures, maximum temperature, and things like that. Okay, when we go to the troubleshooting tab, you see for this component we have pre-insert faults. Faulty opening, cannot reset properly, cannot open, or always fully open. Okay, and there's different ways of triggering these faults. For example, let's say if I say always fully open, okay, and I want to actually trigger this fault with a toggle switch because I want to have like a complete circuit made, and I want to have like 3 or 4 toggle switch that when you flip one up, there's a fault, you can put it back down, flip another one for another fault, you know, for students to actually analyze the circuit. So I'm going to here put the alias, and I'll name this, let's say, fault relief. Okay, and then I'm just going to go here, approve, and close. So now I'm going to take a toggle switch. This is what we want to do on this at this point. It's a bit too big. Let's call this fault relief. Okay, here I can just shrink that. Like I said, it's a bit too big. Okay. And now I need to associate this toggle switch with the fault that we've just created. So when I click twice on the fault relief, I'm going to go to internal links. And you see here, these are all the variables of my schematic. And you see fault relief is here. If I click twice, you'll see at the bottom here, the link is confirmed it is made between the two. And if I close, now let's see what's happening in the simulation. Okay, so let me reduce the flow so we can see more what's going to happen. Okay, let me reduce the flow so it goes slowly. Cylinder extend, but if I flip the switch, you see I just opened my relief because the fault that we set was always fully open. So even though the schematic will not show it is open, triggering the fault will actually cause this fault to happen. And if I turn it off, circuit works normally. Turn it back on, there you go. So the interesting part of this is that the students can actually trigger, you can first start with all the faults off. You can confirm the circuit works well and everything. But then when he turns it on, something is wrong. In this case, it's kind of obvious because, you know, if I just retract here and I flip it, it's kind of obvious to know what the problem is because we see the flow going through the relief, okay? But keep in mind that in your project properties, so you right click on the document and you go document properties. Then you go hydraulic. I'm going to edit this standard. So you click on open and modify here, the icon. And here you can change the properties in simulation of your schematic. So right now, you see that when I open this here bit, it will show me the picture. So you see we have animated. You can remove the animated line. You can remove the arrows that shows where the line goes, the fluid goes. Okay? And if you want to, you can even remove the color in simulation. You see now when it's above 5 bar, it's going to be red. If I click here and I put it black, and I put everything here is going to be black. So I don't want to see anything while I simulate. This is the pressure appearance, flow appearance. Okay. And then if I just do approve, yes. The flow appearance still I would put that black as well. Sorry. Flow appearance also. Okay, this is here. The temperature, sandy stoke, this we don't need. So we've come up with the actual colors. Okay. And then if I close this and I go back in simulation, you see everything is black now. So students will not be helped by the arrow. If I flip this on, you see the problem is there. But I cannot be helped with the arrows showing me where the flow goes or anything. So I actually need to go take some measuring instrument. So I can take like a pressure gauge like that if I want. I push it on the cursors, 2 psi, 60. Oh, come on, I don't have enough pressure in my circuit. What's going on? Or I can use this dynamic measuring tool. Oh, sorry, that's the wrong component. This one is a pressure node, so you need to go on the connection point like that and trace a line to display the pressure. That's my fault. Okay, so this is what you can do. Or if you click on this one here, the first one is on components itself. So I can click on the line, then trace my line, and this will show me, let's say, the flow in liters per minute or GPM, for example. And when I come here, you see I have, so there's flow going through the system, but how come it's not coming out? Okay, do I have flow going here on this piece of line here? Yes, I have the exact same flow. So all my flow is going, and if I take the flow on this line here, I can definitely see that there's no flow going up here, but all the flow going to my pressure relief. So definitely I have a problem with my pressure relief valve. Okay, so then the students can report this fault, turn it back off, and then actually turn another fault on and move on. And then you can erase very easily these measuring box like that. Okay, so this is why. So with Automation Studio, you can create a circuit. You can have the circuit already made on which the students will actually troubleshoot. It's up to you to decide. Okay, and just to show you one more feature, if I click twice again on that pressure relief, remember at the beginning when I talked to you about the operating condition of maximum flow, maximum pressure, and maximum temperature? If I go to troubleshooting again, I could say that this fully open problem will occur with either flipping a fault or actually triggered by if I reach any of these maximum. So for example, if I exceed the maximum flow of the component that it supports, it will automatically fully open. Okay, so this is another type of fault that you can do with this component. Now if we move on to the electrical, so let me just do a new project and we'll launch a AC/DC electrical. We have the same functionality, okay? Let me just do something very quick here. So I'll build like a very simple three-phase motor circuit. So let's say if I go here, I'm just gonna put like I'm not gonna put any contactor. This is, let's say, breaker. Okay, then I'm gonna take like an overload here, a well, and a motor. As simple as like that. Okay. I can, like, again, I'm gonna just put the rotation here. Okay, I'm gonna use the polyphase wire. As you remember in video 2, I'm a bit lazy, so I use these to make much faster connection. And you see, for example, if my motor was here and I rotate it like that, the polyphase wire will automatically, if I go back home, polyphase wire, and I go like this, you see, so it's very quick to do a schematic. So now if I simulate, I don't need that pressure gauge here, so I'm going to take the brake on and then the motor spins. No problem there. I can take my multimeter clamp if I want. I can take measurements on my phase here. Okay, I have about 4 amps. Everything works well. And then, for example, let's say if my overload here is set to 10 amp. Let me open it. Go to the builder. And let's put like a 10 amp here maximum. Okay, 10 amp. Okay. Thermal settings greater than 28 amp. So you see here my minimum thermal setting, 28 amp. Let's put that to 5. And then my 10 is going to work. Okay. I approve and I close. So now, now I want to do something else. Sorry, I'm going to click twice on it. And I'm going to display in the data here. I want to display on my schematic the tripping countdown. Okay, so when I close, you see the time is here. Well, you know, obviously from the past videos that we can go into edit, we can increase the size, we can change the color of this, you know, it doesn't matter. So now if I zoom in a bit more, if I launch simulation, I turn this on. I could have moved down a bit the text for the rotation, but you see it's about 1800 RPM. And I have about 5 amp, 4 amps. If I click on the motor as it spins, I can increase the torque, which will increase the current also. And then if I go above 10 amp, you see my thermal overloads start counting down. So on this circuit, I can do the same thing. If I click on the motor, for example, and I go to troubleshooting, I can jam the water. Okay? Or if you want, if you click on the plus here, you can actually add internal electrical leak through resistance, external leak through resistance, restricted electrical connection through resistance, and severe electrical connection. So for example, if I want to make that the port W is not working on my motor, I would come here, severe break, and choose the port W like that. And then I can flip that with also a switch, exactly like we did with the hydraulic. Okay? But also what you can do, if you click on the line, for example, you can declare the line to be cut. So now what I can do on this circuit, for example, I can click, let's say, on my overload. Let's say I want to make that terminal T1 that it's not working. If I click twice on it, you see we don't have any predefined troubleshooting for this, but I can actually click on the plus here, and I'm going to add, let's say, a severed electrical connection, and this is going to be my T1 here. So this T1 that we saw here before on the circuit will not be, it's going to be open instead of being closed. And this will be called, let's say, fault 1. Let's approve and close. So now if I just go again, take my toggle switch, which is huge right now, but anyway, we'll reduce it after. Okay, just reduce it like that, very easy. And now I'm going to link my fault 1 to trigger that T1 here will not be working anymore. Click twice, internal links, search for fault 1. Okay, hold on. Did I name it fault 1? Hold on. Let me just go back here. Oh, I need to declare it so I can actually connect to it. That was my mistake. Sorry about that. So now if I go here again, that it is declared, then I'm going to see my fault 1 you see here in the variable assignment. Click twice. Now if I simulate, everything worked fine. Let's just take the amp in this phase. So 4.97 amp, everything works well. But then what happened if I flip the fault? There's no more current here. The motor is slowing down. And then something is happening. Okay, so depending on my setting, and you see here, I have like more current than the other phase. If I had like a contact of the overload on my circuit, and I would set the overload correctly, that phase loss would actually trigger the circuit to open after a certain time, and then the students need to figure out, okay, what just happened here? Okay, so we've worked with a customer and we created some faults like that on a circuit, and let me show you that before we move on to the multi-technology, because it's pretty interesting, and I want you to see this. It's that this is actually like a roll-up door. Okay, we have a circuit of a motor control. This customer really wanted to work on a symbol circuit, not illustrated views. Okay, so we have something like this. Well, we have the control circuit, we have the three-phase circuit, and if I start the simulation, this is a message that we decide to add for the students that tell them what they can use during their troubleshooting skills. And now if I, let's say, bring the door up, it works well. Down, everything works well. If I, let's say if I just go move it up again, and then while it goes down, I'm going to trigger an obstruction here. Go down, flip that switch, and then it retracts automatically. And I cannot go down anymore until I remove what's triggering the LS3, then it's going to go down. So as a student, I test this, everything works well, perfect. But then I have a bunch of faults here. So let's say if I bring it up and then I trigger fault 2. Okay, doesn't go up, doesn't go down. Okay, so what's going on? So then I need to use my multimeter, let's say, and actually go take measurements on my circuit. Okay, do I have any voltage coming out here? Yes, I have my 24 volt. And then I can go on and go on. Do I want to test the continuity in a wire? No problem. Let's see if I want to test this here. There is. So you see, so the students need to use this tool to try to figure out the problem. And then once he report to his teacher, okay, fault 1 was blah, 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 then he can turn it back off. And then if I go up and down, now everything works well. Then he can turn skill 2 fault. Go up, it's not going up. Okay, what's going on now? It could be something else. So you really can put a bunch of faults like that and make the students work their way through it and see what the problem is. You see here in the fault 3, it goes up, goes down. How come it stops? At some point it stops. Something is going on. Then, okay, what can it be? I'll tell you, this fault, basically, what it is that it's a intermittent. So there's a problem on a port of C1 here, with the port 10 here, which is actually a loose wire. So sometimes it does a job, and then after a little while it turns off because it's loose. Okay, so but he needs to figure out that this is the problem. Okay, so this is why the Automation Studio is a great tool, because you can put faults on circuits that you're already using with your students. Okay, and I mean you see these faults here. I mean, I can duplicate that and put 12. You saw, okay, like I was telling you at the beginning, this circuit is blocked for students. You see, I cannot move things around. It says missing rights. I cannot click on the motor twice to go see the properties inside. So as a student, there's nothing that can help me here, because all I can use is my multimeter and clamp meter and my measuring tool. So that's why it's important that we can lock the document afterwards, so they don't go and try to figure out, okay, because I can click twice on the component, go into troubleshooting and see what the fault is. But if I can't have access to this, I won't know what happened there. Okay, and the permission like that, we will also implement it on our schematic for the multi-technology circuit. Okay, so let's start now applying some faults on the circuit that we've been doing over the last few weeks. So let's open the project. And we're going to try to apply a couple of faults on different technologies and see what's going to happen on the system. So let's work on this circuit now and insert faults. Okay, so first what I'm going to do, I'm actually going to create a zone to put my buttons for my faults. So I'm going to put a square down here. I'm going to fill up this with red, like this. Let me zoom in a bit while I'm doing this. And then I'm going to put a text here. And I'll call this faults. Simple as that. So I'm going to bring it over here like that. I'm just going to shrink this, it's too much or nothing. And I'm going to put the text white. Edit text white. And why don't I put a line under that to separate the title from the buttons. Whoops, it's a bit crooked. Let's do it again. Like that. And I'll put a bit thicker. And I'll put the line white as well. There we go. Now, like I've been showing in past videos, I like to use toggle switches to actually turn on and off my faults. So I'm going to bring a fault here, a button that I'll call fault 1. Okay, so it's a bit, I'm going to shrink it, it's a bit too big for nothing. This is a good size. Yeah, if I put it here like that, and my fault 1, I'm going to put it a bit thicker, bold and white. So I'm going to use another one here. I'm holding the control key down, copy it like that. 1, 2, 3, let's say we'll do 5 faults. Okay, let me just re-shrink that a bit like this. And shrink the line again. Shrink the text. And my line like that. Okay, so now I have my 5 buttons. Fault 1, I'm going to click twice on it. Change that to fault 2. You see in Automation Studio, if you leave the properties box open like that, if you switch component, it automatically updates with the component selected. So 3. This one put fault 4. If I would have taken the button each time from the library, I could have just renamed them directly. But because these are already at the size that I want, I find it easier to go like this. Fault 5. Now if I zoom out, I have my circuit and my toggle switch to trigger the faults at the bottom. So I can select all this. Let's just move it a bit more like that in the corner. Okay, so note that you can do any kind of fault that you want, but for the purpose today, we're going to create a fault on the start button. We'll create a fault on a proxy. We'll also create a fault on the contactor, create a fault on the contactor. Then we'll create a fault also on the compressor here. and on the output card of the PLC. Okay, so let's do the first one. So let's click twice on the start button. First of all, let me zoom in a bit to show you that if I display the port names, you see the port number 3. That's the port that I want to be disconnected. Okay, so basically what I'm going to do, I'm going to click twice on the button, go into troubleshooting. You see there's nothing that it's preset for this component. So I'm simply going to click on the add here. I'm going to add a severed electrical connection on the port number 3 that we've identified. And I will call this, let's say, fault 1, like this. I approve. And now I close. So I have a fault 1 that I've created, and now what I need to do is I need to assign this toggle switch to the fault 1 that we've done. So I'm going to double click on it, go internal links, and I'm going to filter for F, and oh, you see, this is important. It's a good thing that we're doing like that. If I click twice on it again, I have to make sure that I declared the fault. You see, if I declare it, then it's going to be available to be assigned. Okay, so that's a step I forgot, but it's good that you see how we can do that. Let's click back on the toggle switch. Internal links. You see now my fault 1 is here. So I can simply double click on it. You'll see at the bottom the link is made. And now, if I launch simulation again, so right now, let's just get rid of my multimeter clamp. If I just hit the button start, everything works well. The motor spin, my compressor is turning here, everything works. But what happens if I flip the fault 1? You see, here it's still like it's closed, but look on my PLC what's happening. You see my output 0 just became not activated anymore. If I go here, I take it off, you see now it's activated. Fault 1, it's not activated anymore. So we have the proof that our fault is working well on the push button. Okay, so let's stop simulation. The next fault I want to do, it's going to be on my contactor here. Okay, you see how in order the contactor to be able to work, I need to energize A1 and A11 and A2. Okay, so what I'm going to do, I'm going to create a problem inside this component that one of these ports will be open, so the link will not be made, and therefore I will not be energizing the contactor. So for here, I'm going to click on the component. This is a custom component. You see when I click on this item here, you'll see a new toolbar that just shows up, custom component. If I click here, I can go see the symbol inside this illustrated component, sorry. But if I click on open behavior, then I will see the actual schematic inside this. Okay, so let me just close it again. Well, I know I want to create a fault on A11. That's what we talked about. Okay, so basically I'm going to click twice here, troubleshooting. I'm going to add a fault. So I'm going to create again a cut port A11 that it's not going to be working. So I'm going to call this fault 2. I approve. I have to declare it like we saw before to be able to link to it. I approve. I close. And then I go back to my here, to the home tab, and I just close the editing I just did on this component. So now, like we did for the fault 1, I simply click fault 2 here. Internal link. You see I have fault 2. Click twice on it. And now this is my fault 2. So basically, if I start the simulation again, I hit start. The motor spin. But what if I flip fault 2? You see the motor is stopping here. Slowing down. I can increase the torque if I want to slow down a bit faster. So the motor is spinning here, and then everything seems to be energized. My C1 output 3 is energized. So what's going on? So you see something is wrong inside here. And if I remove the fault, you see, boom, the motor restarts spinning again. So when you create a fault like that, it's kind of hard to know what it is because it's actually not interfering with the simulation or the animation of the component. It just make a connection that is faulty. Okay, so we've done the start, we've done the contactor. What I talked about also, we said we wanted to do one on a proximity sensor. No problem. So I can stop here. I can go on the proximity sensor here, PS1, and do the exact same thing. If I click twice, I go to troubleshooting. I'm going to add another fault. This one will also be a severe electrical connection on port 3, for example. And this will be my fault 3. I approve. I declare it so I can link to it again. And now I'm going to link fault 3, internal links, to fault 3. So again, now if I simulate, you see my PS1 is closed right now. But if I flip fault 3, you see it's still closed here. My light is still open here, but it's not activating on my PLC. If I turn it back off, you see the input 4 just turned on. So now we've created a fault on the proximity sensor. Now let's do one on the PLC card itself. Let's say I want to simulate that my output 0 is not working. So I'm going to click on my card, go to Open Behavior. Here is what we have behind the card to simulate it. So if I click twice on this component, you see this is my B0. So this is my output 0. Okay? So what I'm going to do, I'm going to click on this wire. And I'm going to declare this wire to be cut. So click twice. Troubleshooting. Plus, I'm going to declare again that the wire is cut at port 2, for example. And this will be my fault number 4. So you see it's pretty straightforward how to do this, and then I declare it again to link it. I close, and then when I close this here, I'm going to go back to my circuit, click twice on fault 4, and link it here to fault 4. So now when I simulate, if I do start, you see my out 0 is energized because my sol 1 is energized here. Now my circuit is closed here. That's why there's no air going through it. Okay, but if I flip fault 4, you see my output area is energized, but my sol 1 is not activated on my valve. So then I can troubleshoot and figure out that there's an output on my card that is not actually sending out signal to my sol 1 or the voltage to my solenoid. If I turn it back off, I remove the fault, and now you see the light opens again. The last one I want to do is actually put like, I'm going to take this compressor and actually jam the motor, jam the pump. So if this is jammed, because of a mechanical link between the two, the motor should jam as well, which will make the current increase and then my overload to trip. But in order to make my overload to stop the circuit, I need to actually use a normally closed contact of this overload, which I'm not using this at this point. So I'm just going to bypass here and actually come and go through my normally closed contact of my overload, like this. Okay? So now, if I just click twice on my compressor, I go here, open behavior, and then I'm going to click, okay, on this one there's a little problem right now, okay, that will be fixed very shortly. There's a mechanical link on the compressor pneumatic, have some issues. So what I've done is I've actually put one in parallel, which is hydraulically driven, and this one I'll be able to actually go to troubleshooting and jam the water. Okay, so this will be fixed very soon, so that's why I'm showing it to you now. I'm being honest with you to say what I'm going to do for the compressor, but very soon you'll be able to do it directly on the pneumatic one. Okay. So I'm going to activate this, and this will be fault 5. Like this, I approve. And when I close my illustrated component. And now I'm going to click twice on fault 5 and link that to fault 5. So now if I simulate, let's take my amp meter now. This is going to be important. So right now if I go to amp and I measure the amp on the motor, if I do start, the current went up at beginning and then it stabilized. And it's running now. Now, obviously, the motor you can adjust it. I mean, I just use the motor that we have here, but you can set the starting current, the current, and things like that in your motor. That's not a problem, okay? But just so we see what's going to happen when we trip fault 5. I trip fault 5, compressor jam, and then my overload trip right away. So what's happening? If I just reset my overload, right away it goes really high on current and trips again. So what could cause this issue? So then I need to go through the system, try to figure out what could be the problem, and so on. Okay, so and then if I take it off and I just reset my overload, boom, everything works fine again. Okay, so this is how we can apply faults on the schematic on different technologies using either the symbols or using also the illustrated components. Okay, so this is what I want to do for this circuit. So let's just save it now. As you saw at the beginning, now the file have faults set inside, but if I'm a student, nothing stopped me from clicking twice on the motor and actually take a look at the configuration of the motor, or click twice on the start here to actually figure out that if I go in troubleshooting, I can see that there's a fault to it. You know what I mean? So this is something that we don't want the student to have access to. Okay, so for this part, I'm going to show you how to modify the permission on a specific project. Okay? Okay, the way I'm showing it to you now for the permission, it's a way that I've done my file already on Automation Studio, and then I want to lock it afterwards, okay? Because at the end, I'll show you that you can create a template of a document on which you will create your schematic on from scratch, and this one will automatically have the protection that you want. Okay, it's much easier, but now this is a bit more tricky because it's already done, and I want to apply faults to it. So something very important. If we open the Project Explorer, you see at the bottom right now, we are connected as anonymous. Basically, every time you launch the software, okay, you're always anonymous. Every user of Automation Studio is anonymous by default, okay? So what we need to do is we need to create another profile, which we'll call instructor, and with the profile instructor, I will actually put restriction for the anonymous account. So everyone that's going to open the file will have the restriction applied because by default, like I said, everybody is anonymous. Okay, so to do that, all I need to do, I'm just going to just lock the Project Explorer here because it's important that we see the information. So I will go into Tools, and here is my connection profiles in the software. So if I click on connection profiles, you see right now we have only anonymous, and this is automatically connection. So every time we launch Automation Studio, it automatically connects to anonymous. So we'll need to create a new one. In Automation Studio, we have pre-created an instructor account. Okay, so you're going to go here, username and password. The username is instructor, and the password is, you don't want to click remember password because anybody who logs onto your computer will automatically be connected to an instructor. Something important, what I'm doing now, I'm actually doing it only on this computer, okay? So even though on your computer, once you launch the software, it's going to ask you if you want to connect using the instructor profile or the anonymous profile, on every other computer, that will not be a question asked because it's only done on this particular machine, okay? Okay, here I forgot to mention that the information here that you'll need to enter is actually the information that you use to connect to your license. Okay, to see this, let's just close this. We'll do it again, no problem. License, sorry, here you go to license, and then you see the license configuration. You go license configuration here. And then this is where you'll copy the information that it's already written. This will give you the path to connect to either our server or to your server. Okay, so you just write that somewhere, and then this is what we'll need to put in when we create the new profile. Okay, so let's go back to the profile now. So let's do the plus again. It won't be long. Let's do username and password. As we noticed, instructor, password. And now here is I need to put the exact information that we just noticed on the other window. And here you enter your key the way it's connecting. Me, I know it's just this here like that. And if I do, and I'm going to name this profile instructor. I approve. Okay. And now what I need to do, I need to remove the automatic connection. So when I launch Automation Studio, it will ask me who is connecting. Okay. But then I need to go to the permission here. So you see now in the user account, I can simply click here to import users that are already been created, like instructor like this. And now you see my instructor that we've done, it's here and has administrative right on this file. So now I need to close this. You see it's automatically saving my project with the new profile that I've created. So now, if I close Automation Studio and relaunch it, you see the software is asking me, okay, who's connecting? So I want to connect as an instructor. I select, it's asking me for the password. And now let's see if I'm connected as an instructor. So by default, it reopens the last project that I've used. I mean, not the last template that I've used. And now if you see on the Project Explorer at the bottom, I'm connected as an instructor. So let's open our project that we've been working on. So let's open my Part 4 final that I just saved. So that's my project. You see I'm still instructor. Now I'm going to go into the tools, permission, and from here I'm going to create a new profile, okay? And this profile here will be called, let's say, students. Okay, or it could be anonymous, it could be everyone, you know, like let's say everyone. Okay, and this profile will be applied to anonymous. And with this profile, I'm going to go to permissions. And this is where you can decide what you will grant or not for this user. So first of all, I want them to do troubleshooting here. So imagine in this case here, I can actually lock the simulation because I want to test the schematic skills of my students. I don't want them to be able to simulate. I want them to create the circuit. And when they think it's going to work well, they just send me the file and I'm as instructor so I can simulate and test their circuit. Okay, there's two things here. You can learn how to troubleshoot or learn how to create schematic. So, okay, do I want them to use the dynamic measuring instrument? Yes, for sure. Do I want them to see the component failure access? No, denied. Functional group? No. Insertion pace? No. Layer access? No. Modification of technological? No. Basically, it's all no besides I want them to be able to use the plotter. Okay, that could be something important for them. I want them to be able to simulate, and everything else will be not not accessible. Okay, so we have the variable manager access. We don't want them to see it. We don't want them to access the properties of each component. We don't want them to move, delete, or change anything on the circuit. We want them to use the dynamic measuring tool, the plotter, and to be able to simulate. So then if I do apply, okay, so this will be now for the profile everyone. Okay, now we don't want anonymous account to modify what we've done. So we just need to go back to user account and uncheck the administrator part on the anonymous. This needs to be done only, there's a couple of validation as you can see, but when you remove that, then when the students will connect, they will not even have access to go to the permissions and connection profile. Okay, so it's important that you do that. Once this is done, we close. You'll see that it saves again the project. And now let's close this again and reopen it as a student. Okay, so let's close Automation Studio. Relaunch it again. This time I'm choosing anonymous. And then once we reopen the file that we just did, you'll see what happens. So you see, if I have created like a blank sheet and assign all these permissions on that blank sheet, as an instructor, I could do everything, make my circuit and everything like that. And then as soon as I send this file to a student, when he opens it, he would have all the restriction of the anonymous that I decide. Okay? Because we're doing the other way around, like I said at the beginning, it's a bit more tricky, a couple of more steps, but it still works. Okay, so I could have removed the open a blank document by default, but okay, so I'm anonymous right now, as you can see here at the bottom. Let's open our project. Let's close this one first, and let's open project for final. Remember now, I'm like a student that opened the file from his computer or whatever, and by default, I'm anonymous. So here's the file. Then let's say I want to click twice on the motor. You see, you do not have the right to access technological component properties. Okay. Let's say I want to move this. You have no right to move something. Let's say I want to erase that. Delete. Yeah, I cannot delete. So you see, there's nothing I can do as a student. All I can do is move around, zoom in, zoom out, do the simulation, start simulation, activate the circuit, energize the pneumatic part so we can see the entire circuit working now after 3 seconds as we track extend. And then suddenly, let's flip a fault. Oh, the motor stopped. And this is not going on anymore. What the issue is. So you see, so we have access to the main things here, but we cannot see what is being modified on the circuit. Just simulate, take measurements. You see, I can still use my measuring tool like this. Okay, do I have any current here? And move on and so on. Okay, so this is what we could do. We can use the multimeter, we can use the oscilloscope, all kinds of tools, but we cannot modify or see what was done to the circuit. So this ends the presentation of today for inserting faults and how to set permission. So over the past 4 weeks, again, we've done the illustrated pneumatic. Part 2, we've done the electrical part. Part 3, we've done the PLC. And now part 4, we just assigned the faults to the program, to the project, sorry. So again, thank you very much for your time. And we are open now to actually take your question. I will answer the questions that were written in the question part of GoToMeeting. Or if you actually want to speak out your question, raise your hand and I'm going to give you the mic so you can ask your question. So thank you very much again for your time. And if you have any other requests, please don't hesitate to contact us. We're always here to help. So thanks again.